So let's take this pulley question here. It says that there are two masses M and M, capital M and small m respectively, hanging from a massless and a frictionless pulley. So this pulley is doesn't have a considerable weight and friction, and in this case capital M is greater than, so the mass of the this block is bigger than the second block. So we need to find the acceleration of the system and the tension in the string. So let us get started. The first thing that we need to do is to draw the free body diagram here. So in this case, obviously, since it is bigger mass, so it is of course that it is going to move in the downward direction. So let the acceleration of the system be a, and this mass is having a weight, total weight that is acting downward is mg, and let this tension be t. Right, so the string will also give a tension force, so this tension be t. So since this tension, this is the same string, the same tension will be propagated on the other side of the string as well, so this also will be t. And here the downward acting force will be of course mg, and this mass is moving down, then of course this mass is moving m in the upward direction. So if we draw a separate free body diagram for each of these masses, then so this is the first mass, the bigger one, acting downward is mg. We have force, the tension force is t, and since it is moving down with acceleration a, the equivalent force for this acceleration will be what? Ma, right? Capital M into a. Now, what is the resultant force that is causing this acceleration? That is nothing but this downward weight minus the tension force. So we will write our first equation, mg minus t is, this is what is causing this acceleration, means the resultant force which is responsible for the acceleration, right? So that is nothing but your ma. So this becomes our first equation. Now similarly, let's draw the free body diagram for the second mass. So the second mass is, again let me draw in a different color, so it's small m, and its weight is acting downward, the tension is acting in the top direction, in the upward direction, and this is moving in the upward direction because the string is going down on the other side. So now trying to equate this again, so what is the equivalent force that will be responsible for this acceleration? Small m into a. So let us write this. Now since t is actually responsible, t is pulling it upward, right? So we will say t minus small mg is causing this overall acceleration. Nothing but the resultant force acting on this is equal to ma. So this is our second equation. If we simply add these two equations, so it will become m minus m into g is equal to m plus m into a. Right? So nothing but we get our a equal to m minus m, capital M minus m, by m plus m, small m. Let me do it better. So m into g. So this is our acceleration, right? So we got the acceleration. Now we need to find the tension. So tension is simple. We can just replace in one of these equations. So let us take the first equation. So, so in the first equation, let me put this. So tension T is equal to m minus m into, right, g minus a. Right. This is what we are getting. So let us replace the values. G minus, what is the value of a? A is m minus small m divided by m plus small m into g. Right, so let us take that g outside, mg into, so m plus m, m plus m comes on the top, minus capital M plus small m divided by m plus m. Okay, let's pull it a little bit upward. So, which means that this is equal to, we get rid of these two, so we'll get 2m plus m is 2m into m by m plus m into g. This is the tension, right? So these are the answers for us. Tension in the string. Okay, so we got the values of the tension and the acceleration across. And this is our acceleration. Thank you.